explorers. Today we are going to look at another day of exploring parameter changes, and we're going to base it off of the parent function, which is y equals x squared. So this is our very basic parent function, and we want to see what happens when we have parentheses. Say that we have parentheses x plus 5 and a parentheses squared. So f of x equals parentheses x plus 5 squared. So if you had to make a guess, what do you think would happen if you have parentheses squared? So we already talked briefly that day that we did some exploring, is that when we have these parentheses lie. And so this plus would make you believe that your vertice would move to the right, but parentheses lie. And so if you were to put parentheses x plus 5 squared, this means our vertice is going to move horizontally to the left, 5. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5. So my vertice is going to move 5 over. And so this is going to be a horizontal shift, 5. So my vertice has moved 5. And so this is x plus 5 squared. So parentheses is how I'm going to get my horizontally shift. So this is going to move horizontally, left 5 units is what's happening to this right here. So if I have parentheses x minus 5 and a parentheses squared, so I know that parentheses lie. So parentheses lie, and if this is a minus 5, I'm going to go to the right. So my vertice is going to move, or my vertex is going to move 5 to the right. 1, 1, 2, 3, 4, 5. So I've moved over 5 in this direction. And so these are just a rough sketch. And so this right here is x minus 5 squared. And so this right here is that we've moved horizontally right 5 units. And we know that parentheses, these parentheses right here, parentheses lie, is a way that we remember that. And it all has to do with the vertex form, where we have to have everything in the form x minus. And so this is a minus a negative 5, and that is the reason that we've moved over this direction. Okay? Just like this is, if I have to have it in vertex form, this is going to be x minus a positive 5, and that is why this is moved over, and this is a positive 5. Okay. So we're going to describe the changes in y equals x squared, which is our parent function, and we're not going to put these into the calculator. We're going to just look at these. And so I see parentheses, and whenever I see parentheses, then I know that this is how I've gotten my horizontal. So I've moved horizontally 1 unit left. And my vertex is now at negative 1, 0. Looking at number 2, I see that parentheses have lied. And so this tells me that I'm going to move to the right 3 horizontally. And so I'll go horizontally right 3 units. And I am moving my vertex. So my vertex is now at 3, 0. This right here, up here, is my vertex that I've moved from 0, 0, and it is over 1, 2, 3. So my vertex is at 3, 0. All right, so looking at number 3, and so I'm going to take it piece by piece. And so this negative right here tells me that's a reflection. And so that's a reflection across the x-axis. Oops. And now that I have parentheses, this is how I've gotten my horizontal. And so the x minus 7 end of parentheses, that's going to be my horizontal movement. So I've moved horizontally 7 units. to the left. And so I know that my parabola is going to be upside down. My vertex is going to be at the opposite of that. And so my vertex is at 7, 0. All right, so I want you to go try, see if you can come up with number 4 and number 4, 5, and 6, and then we'll compare answers. All right, so looking at number 4, this negative tells me that this is a reflection. This is a reflection across the x-axis because this negative is outside the parentheses. Then I move as I go left to right. This plus 4 inside the parentheses tells me that this is where I get my horizontal movement, and so I've moved horizontally left. And so my vertex has now moved to -4, 0. On number 5, I do not have any parentheses, so there's no horizontal movement. This negative tells me it's a reflection across the x-axis. This 1/3 tells me it is a vertical compression. And this 1/3 just tells me that this is the scale factor. Everything is being multiplied by, and so it is a scale factor of 1/3. I also know that it's going to be upside down, and it's going to be a fairly wide graph because of this 1/3. On number 6, there's no horizontal movement because there's no parentheses. I know this is a vertical stretch, and so it should be fairly narrow. The 2 tells me it's a scale factor of 2, and my vertex is at 0, 0. So we're going to go try number 7 and 8, and we'll compare answers. Number 7, this negative right here tells me that it opens down, so it's a reflection across the x-axis. And I know that this -4 tells me that I've translated my vertex 4 units down, so 1, 2, 3, 4. So my graph would look similar to something like this, and I moved my vertex 4 units down, so my vertex is at 0, -4. And so all I'm doing is trying to figure out where my vertex is pretty much all these are telling me. On number 8, start with my parent function right here, which is x squared. Normally my vertex is at 0, 0. This tells me I'm taking my parent function and I'm moving it up 3, 1, 2, 3. So now this is my parent function that I've moved vertically up 3 units. Okay, so now we're going to write equations. So what we want to do is that everything is based off of where our vertex is. And so my vertex in relation to the origin, I can see that I can count how many spaces that it's moved. And so I've moved from 0, 0, my vertex has moved over to 1, 0. And so I know that I have some type of movement, horizontal movement. So I do have horizontal movement. The only way that I can get horizontal movement is by having parentheses. So my equation will be y is equal to, I do not have any vertical movement, so I'm not going to have anything plus c. So I'll have my parentheses, and then I'll have x, and then I need to go in and get to the right. In order to get to the right, I'm going to have x minus, and then I've moved my vertex 1 unit, and so x minus 1 squared. So that is my equation. Looking at number 10, so I want to find out my vertex has moved from the origin. I'm going to count over how many places it's moved. So 1, 2, so my vertex has moved left, which is horizontal. And so to get horizontally, I have to have parentheses. And I also know that this is a reflection, and so I have to have a negative. So I have to have 2 sides, so y is equal to, in order to get that upside down movement, I have to have the negative on the outside, and then I'm going to have x, and then to get to the left, if I'm going to have to the left, I know parentheses lie, I'm going to have plus 2, and that will be squared. So let's see if you can go in and see if you can figure out what 11 and 12 is going to be. First, you have to determine, do I have horizontal movement or do I have vertical movement? So on number 11, my vertex has moved down, so there's no horizontal movement, so I do not have any parentheses. And so in order to move vertically down, I'm going to have a minus 3 because that is my c, so I'll have x squared minus 3. And I can have y, or I can say f of x. On number 12, I do not have any horizontal, so there's no parentheses, and I just have f of x. This is upside down, and so that's going to be negative x squared, and then my vertex is up 2, so that's where the plus 2 comes in. So our vertex form is y equals a parentheses x minus h squared plus c. So this is worth memorizing. Y equals a parentheses x minus h squared plus c. So the A basically tells you how wide or how skinny it is, and your H and your C is going to be your vertex. So C is the vertical shift, H is your horizontal shift, so x minus h shifts right, x plus h shifts left. The A is your stretch or your shrink, and negative A is a reflection. So these are all the rules that we have been talking about. All right, so we're going to go ahead and work on number 13, and this is just a summary of everything that we've been talking about. So we always start left to right, and so this negative right here tells us this is a reflection across the x-axis. Then I look to see I have parentheses, and this right here is going to be, this 2 tells me I have a horizontal. And so this is going to go horizontally. This plus tells me that I'm going to go to the left. So I have horizontal, left 2 units. And this is my C value. And this tells me that I've shifted, and all this is moving my vertex. And this tells me that I've shifted vertically down 1 unit. And so up here, we saw that the H and the C, the negative H and C, that's my vertex. And so my vertex is going to be a negative 2, negative 1, right here. So opposite of this and that negative and this value right here. So my vertex is negative 2, negative 1. So why don't you go try number 16? Tell me what's happening, and then tell me what your vertex is. All right, so you should have worked question number 16 for me, and that is a reflection across the x-axis. It is a vertical stretch by a scale factor of 3. So your parabola is going to be, it's going to be facing down. It is going to be fairly narrow. It's going to be moved horizontally right 4 units, and then it's going to be moved vertically up 2. So then our vertex is, if we look here, we know our parentheses lie, and so remember that our vertex has to be written in the form x minus, and so x minus a positive 4 is how that is, and so the first part of my vertex is a positive 4, which is the x value, and then the c, and so my vertex is now at 4, 2. All right, so we need to tell whether which parent function belongs to these two graphs. So the first thing we have to do is we have to identify whether they're linear or they're quadratic. So in order to tell whether a graph is linear, you could go in and do your lists and spreadsheets, and you could graph, and you can look and see if this is a straight line, and then you can go and put this in your lists and spreadsheets and see if this is quadratic. Or you can go ahead, and linear has a constant rate of change is what we're going to go look at. So it has a constant rate of change, or has a rate of change. And so we're going to go in and we're going to pick 2 slopes, or you can go find the common difference between all of these. We want to make sure that our slope is the same. And so we're going to go find the slope between these 2 points, and then we'll go in and find the slope between these 2 points. And we want to make sure that the slope is the same for this whole table. So go find the slope, and then we'll compare. All right, so we have 2 functions are shown below. We want to tell the parent function for each set of data. So first thing you have to do is that you have to determine whether it's going to be linear or quadratic. And so if it's linear, then it'll have a constant rate of change. So what I want you to go do is I want you to go find the slope. Pick 2 points, find the slope, and then pick 2 other points, find the slope, and make sure that they are the same. So what you should have found is that the slope up here was -1, and the slope between these 2 points down here is a -1. So your slope is going to be the same wherever you are on that line. So that means that this is a constant rate of change. So this is going to be linear. And the parent function for a linear is going to be y is equal to the x. Y equals x. That is your parent function. And remember that y equals x looks something like this. It goes straight through the origin. So that's what y is equal to x looks like. All right, you could also go in and put this in lists and spreadsheets and take a look what it looks like. You can also go type letter B in lists and spreadsheets and see what that looks like, but I'm going to show you another way. One way you could go in, and we know that the axis of symmetry divides that in half, and so when you look at -1 and 1, the ordered pairs, you should see that -1 and -1 here, and your ordered pair -2, 2, and 2, 2 right here. That should tell you that this is going to be quadratic. But we're going to look at something else that will help us also. So what we want to do is we want to look at the second difference. The second difference. And so we're going to go in and take 2 minus a -1, and that's going to give us 3. We'll take a -1 minus a -2, and that's going to give us 1. We'll take a -2 minus a -1, and that's going to give us a -1. And then we'll take a -1 minus 2, and that's going to give us a -3. And then we'll have 2 minus 7, which is equals -5. So just looking at that first difference, we can already tell that this is not going to be linear, because these first differences are all different, whereas on a linear, the differences would be the same. So now we're going to look at the second difference. And so we're going to look at 3 minus 1, which is 2. We're going to look at 1 minus a -1, which is 2. A -1 minus a -3, which is 2. And then -3 minus a -5, which is 2. So this second difference right here, if it's the same, then that tells you that this is the quadratic. So you would take the second difference if it's the same, it's going to be quadratic. Is quadratic. If the first difference is the same, it's linear. If the second difference is the same, it's quadratic. So my parent function is y is equal to x squared. All right, so for your homework, you will be picking out what is happening to the parent function. And so if you look at number 1, you'll see that you have these parentheses. And so for your parentheses, you know that you're going to have horizontal movement. So this is going to be horizontal. So this moved horizontally left, this went horizontally right, 6, and that's all. And so just additional information, your vertex is at 6, 0. On number 3, this negative right here tells you that it's a reflection, and that's going to be across the x-axis. This -2 tells you that this is horizontally, so that moved horizontally. And this minus tells you that it went to the right, 2, and my vertex is at 2, 0. And so that's what you'll be doing. You'll be telling me what is happening to your parabola.